Okay, so just a couple more things. So the volcano. So the volcano that we get here, if I just point to various points of this, is this one here. And this is called a fissure volcano. Let's just write that on there. Capitals. So characteristics. It's very, very flat, very, very gentle sloping. It has a VEI, so volcanic explosivity index of 1. They're very, very low key. And the eruption, what happens is, it happens along the fissure, which is a crack in the crust. So this lava that's coming out here shoots up in a fountain. It's literally a lava, but it's a fountain rather, but it's made of lava. And the lava's quite runny. The type of lava you actually get is basalt, which would be quite like runny gravy. Example, great word, is Ajafjalajokal. Ideally, you need to be able to spell that, not say it, but spell it. So that's the fissure eruption. So that is, just going back to the big diagram, that would be here at the ridge push. Just to give you a bit of an overview, because we always like to do a location map. Let's just write that on there in the bottom right hand corner. So here's your Americas, here's Europe, and this jaggedy line here is the mid-Atlantic ridge. Now you'll notice that it's not a completely straight line. Iceland, there it is, popped up in the north. Now it's not in a straight line, really simply, because you've got, let's draw the arrow there really, two arrows there, which is the gravitational sliding. The gravitational sliding is happening at different speeds. So if it's happening quicker, it's dragging the plate that way a bit quicker. If it's happening slower this side, then that's obviously pulling quicker than that one. And it's just making the crack, the ridge, so this here, to actually have this shape. On the PowerPoint, I think it's, I'm just looking now, I think it's slide number 5, you will see a kind of an artist's view of what it looks like, and it looks like a snake kind of coming down through the Atlantic Ocean. Just one other thing that I slightly omitted. So I talked about how the ridge, you get remnants of it here. Now, if you're not getting that, don't worry too much. Also, there's a name for these. They're called seamounts and guyots. Again, don't worry about that too much. In fact, let me just flick to the screen. So that's the picture I'm on about. Now, if you look at that there, so obviously there's the UK. Iceland is a little bit further north, you can't see that, but look how it snakes, the ridge snakes. So that's an artist's impression of what that ridge would look like in the Atlantic Ocean. Now, if you look at it, you've got, it kind of goes straight there, then it goes that way, and then it goes back up that way, then that way, and then that way. So that is to do with just the difference in the speed of the gravitational sliding. That's what it would look like. Now the remnants of the ridge, so all this area to the right and all this area to the left, that area there would have been the ridge at some point, but the gravitational sliding is pulling this bit that way and pulling this bit that way. So when you've got these what look like little mini volcanoes, they would have once been in the very, very centre of the ridge. And they've probably just resisted erosion on the bed of the seabed actually just a little bit more, and that's why they're left like they are. Hope that helps.